thank you so much for coming on the show. It's great to finally meet you because this is how we meet each other nowadays, through Zoom. So why don't you tell us a little bit about yourself and your organization and what you're passionate about?
Great. So my name is Kurt Busch. I am co-founder and CEO of Syntiant Corp, and we were started in 2017 to bring AI to edge devices. We had
Wait a
seen
second.
that.
Wait a second. AI's been around that long? I thought it just came out last year.
No, actually, I think AI has been along for quite some time. NVIDIA started working on AI software probably in, I think 2003, something like that, plus or minus a few years.
Well,
And what we had seen is that the economics of compute it was really starting to change. I mean, even back in kind of the end of 2016, we saw what GPUs were doing in processing in the data center. And it was just kind of a sign and portent about what was going to happen in the future. And we said to ourselves, if AI is this important in the data center, what is the equivalent thing in edge devices? And we saw the world and we said, okay, let's take what's playing on in the data center and make it really pervasive. Let's make AI something that you don't need to be connected to a data center for, and really make it something that's useful for just about anybody. And since then we've let's say fast forward 7 years. Gosh, it feels like 20. But fast forward 7 years, we have about 50 million devices in the field today that use our technology,
nice.
our hardware, our software. And we're really trying to make Edge AI a reality. And I think we're on a very good stepping stone to do that.
Awesome. So what's the upside of using you as opposed to somebody else?
Well, if you look at what it takes to actually do AI, one, you need some kind of processing. And what we did is we have a very experienced team, probably 20 to 30 years experience building low power processing. Before this, it was largely in the networking space. And what you want to do is you want to have the most amount of processing in some kind of constrained environment. So, we see that with GPUs today. People are using GPUs versus traditional compute to do data centers. We're doing the same for low power devices. So our devices are used in things as small as hearing aids to as large as automobiles.
Wow.
And so what we've done on the hardware side is that we bring about 100x dividends. So compared to traditional compute, we can give you the same amount of processing at 100 times lower power, or we can do 100 times the processing at the same power envelope. So that's really important. So that's step one. Step two is you need to be able to interpret the outside world. We look at Edge AI as really this bridge between the real world and the digital world. And if we look at what does that mean, right? I mean, we've talked about how do I get to from the real world to the digital world? We've often called that interface. And I look historically as what has our interfaces been? The first one was keyboards, and that gave us MS-DOS, and that was about 150 million units a year. The second interface we had was the mouse, and that gave us about 500 million units a year with Windows type applications. Then along came the touchscreen, and that was our third interface. And that enabled the smartphone, and let's call that 1.5 billion. So every time the interface gets easier, you need to be able to, it basically increases the volume of whatever widget it's connected to by like 3x.
Right.
And to do this, you need a lot of data. So, how do you interface between the real world to the physical, or the physical world and the real world? We think the future is natural interfaces. We're talking today. You have an AI assistant with a natural interface on this call right this very second. So, we're almost there. So, what could this be, right? Conversational speech, wake words, computer vision, different sensors, events, whatnot. So you need data. So we need hardware and we need data to be able to do this. And the third thing you need is to be able to interpret this data and make something useful. And this is really where Syntiant excels, is that we realized early on that just doing hardware was not sufficient. In fact, I like to say that it's sort of like a fish with a bicycle. It's interesting, but not that useful. So we invested a huge amount of money. In fact, about 80% of our engineers are software engineers building AI models. And we actually have an AI model business. So we sell models in addition to our own silicon. We sell models for other people's silicon. And we have these turnkey models for people. So if they want to have things like wake words or person detection or pet detection or package detection, or detect things like glass break or other types of full automatic speech recognition. Do you want to say, you know, what did this person say, or do you want the other way around, text to speech? So these are the three components that really we're trying to bring to the market. And again, you know, there's 50 million plus units, you know, deployed today, and every day there's more and more. So I think we're doing a decent job. It's still early innings. You know, if people use a baseball analogy, you know, what inning you're in, I think we're in spring training.
Right. We're not on the fields yet. We're on
not.
some of the field. But so the biggest thing, I mean, whenever I ever heard about edge computing and edge anything, was the sort of latency issues. I mean, how do you get over that?
Yeah, no, that's really the trick. So, you know, why, so, you know, people often say, you know, why do I want to move something from the cloud that's working great to something in the edge, right? And in the cloud, you effectively have unlimited resources to something that has limited resources.
Yeah, exactly. When you're talking about a hearing aid, I'm like, wait a minute. I mean, that's tiny.
Yeah, you can't go to the cloud for a hearing aid, right? It's not going to work. You have, you know, a very small.
Can you imagine if your hearing aids had to be network connected all the time? That would not work too well.
It wouldn't work. The round trip delay would be horrible.
Yeah.
So there's 4 advantages to Edge AI. And latency is one of the biggest ones. So, you know, I have a video doorbell at home that does its person detection in the cloud. And with that video doorbell, I often miss people because I say only trigger on people. I don't want you to trigger on trees or, you know, anything. So I miss people because it goes to the cloud for this round trip delay. There are video doorbells that use Syntiant technology. I haven't installed one at my house yet. I need to, but I haven't done it yet, that have instantaneous response. So they're getting extremely good customer
because the code is actually in the doorbell.
It's in the doorbell.
Yeah.
So when a person, a pet, a package goes by that doorbell, it's instantaneous. So you're not have this multi-second round trip delay. Right. So latency is one, but there's 3 other ones that I think are actually also quite compelling. One, the second one, let's call it power. By doing the AI in a low power device in a product versus doing it in the cloud, you save all of the power from the radio going to and from the cloud, and that can make a processor that really was not designed for battery powered. You basically can do it in battery powered if you do a low ultimate
or
low
solar
power.
or any of these low power.
Exactly. You could do it in solar. You could do energy harvesting. You know, things like that. You know, you can measure. Say you're doing predictive maintenance on a machine, and you want to power the device and the AI purely based on the vibration of the machine. These are the kind of things that you can do with
very cool
low power Edge AI. So that's the second one is power. The third is privacy. Is if you're doing AI in the cloud, everything's going there. And, you know, I like to take the example of a license plate detector, right? So if you have a traffic light or an intersection, and, you know, I really don't want every license plate, specifically my license plate, recorded into the cloud, even though probably my phone provider knows exactly where I am. But let's just say that, you know, I don't want every license plate go to the cloud. But if I have a license plate detector that's done at the edge, instead of sending every license plate that goes through that intersection, it just says, hey, I found it. I found the license plate, and it does it instantaneously. So then it could notify whatever authority that here's the license plate, it's going this direction. And then the last, probably the fourth one, and maybe the most important, is by doing Edge AI, you can reduce your cloud, basically the packets going to the cloud, by about 90%. And we have a lot of customers that we've done case studies with where we see a 90% reduction, or no, pardon me, 99% reduction of data going to the data center, going to the cloud. And then that in turn turns into about a 90% reduction in cloud cost. So you've really,
because those cloud costs are like,
tremendous.
People don't realize how much those are. Those are massive.
Exactly.
Massive.
So, you know, say you have some product that your customer is paying, you know, $4 a month for, and your cloud cost is $3, and suddenly you can get your cloud costs down to, you know, under 50 cents.
Nice.
You know, your profitability goes way up, and then maybe you can reduce the customer expense as well. So you really can make and edge, everyone can take advantage of it, right? It reduces the cost, and you can sell higher volumes, and then have better edge AI type products.
Well, this sounds fantastic, but how come it hasn't been done till now? Like, what was the trigger that made it possible?
So there's a couple of things you needed. You got to put all this stuff together. So
Yeah.
one is you need a silicon architecture that's good at low power processing. So there
Mm.
was not a good one, prior to Syntiant, and there's some competitors now, but I think we're quite a bit ahead of anything else that's out there. Second is you needed platforms that you can train AI on.
Mm.
There weren't, prior to TensorFlow and PyTorch and things like this, I'm going back to, pre 2017, there really just wasn't a way to do, good training of machine learning.
Mm.
And lastly, there wasn't really this way of collecting data, cleaning data, and making it useful to people. So, it's the garbage in, garbage out is, it's never been more true than with
Right.
AI processing. So with the advent of big data, and then followed by tools to use specifically for edge AI, all these things are starting to become available. So we built a lot of these ourselves. We built our own data cleaning and collection tools. So it took me, many years to do that. And then, now there's more and more data out there. So the more data there's available, the better tools to clean it. And then you have the training platform. So, it's all coming together, but it's, you can't do it all at one time. So this is measured in years.
So are these advances where they're putting out smaller and smaller models? Is that something that you're using, or
Yeah,
are you building your
it
own?
tremendously helps edge AI.
Mm.
Because if you look at it, kind of how models have been developed, is that you generally just want it to work. You build a resource constrained model. It has tremendous amount of parameters. You run it on a GPU in the cloud, and you get a result, and you tell everyone, look, my result's great. And then they say, well, I want to put it in this edge device. Like, oh my goodness, it's 100 times too big. So then you figure out, what kind of things that you can do to shrink it, right? So you can do things like quantization, which is just a fancy word for going from 8 bits to 4 bits to 2 bits to 1 bit, or 16
Hmm.
and so on, or going from a full floating point number to an integer, and then going to a smaller integer. So you
Right.
look at those kind of things.
Just practical things.
Yeah, very, very, but you got to make sure you don't break it, right?
Yeah.
So it's actually fairly easy to shrink and break these things. Often they're brittle. Is the
Mm.
smallest change will break these things, and you need to be able to deploy. If you want to deploy millions of them, it can't be brittle. It has to
Right.
be rock solid. Um,
Especially in the kind of devices you're talking about, they're going to be out there in the real world.
Exactly. I mean, if you're like in a remote control or a hearing aid or an automobile, no one wants to recall these things.
Yeah.
There's just not enough money to do it. And then
Hmm.
they and then you look at kind of things like, okay, is there sparsity, which is basically just looking at computations you don't need to do. So, times zero and things like that. So
Right.
there's methodologies, but you don't do those methodologies until you have something working to begin with.
Right.
And so it takes time. Again, can't turn everything over just right away.
Nice. So can you give me some of the use cases that you're working on right now, just in
Sure.
general?
Sure. So as I said, most of edge AI that we're doing is detecting something.
Mm.
So we do computer vision, and the computer vision is we look at people, we look at pets, we look at packages. We also look at things in the wild. So we look at animals, all kinds of animals, both sounds and visual.
Nice.
Um, we look for events. So we're doing security. So is it an automobile glass break? Is it
Mm.
a house glass break? And the neat thing about AI is you can train an AI to tell the difference between you dropping a plate in the sink or on the floor and an external window breaking.
Right.
So, often, if you have an alarm system with like a last generation glass detector, they say don't put them in the kitchen, and
Right.
don't have your alarm on when
Or
you're
smoke detectors, right?
yeah, exactly, all
Depending on
those things.
what kind of a cook you are.
Exactly. But with sentient based AI, you could actually put these things right in the kitchen,
Mm.
and it can tell the difference between an external window breaking and banging some silverware together, or
Yeah.
dropping a
So
cup or
do
something.
you have to give it specific training on site, or can you just give it generalized training and it'll know what it's doing?
Yeah, the only way to scale is to do this all general.
Right.
So you take, let's call tens of thousands of data points, you train up a model and then you deploy in the field. And what you can do, and this is really why first mover advantage is so important, is that you can collect data in the field. So say it doesn't work, you get that data, then you improve your model, and you get that data and you improve your model. So once you've been deployed for, let's call 5 years, you have this barrier to entry versus any competition that's almost insurmountable,
Right.
because you can't do those use cases in your own lab.
Right.
And if you have, hundreds of thousands or millions in the field that you've been constantly getting this feedback, then you can really improve your model. But you don't want to improve your model per household. You want to improve your model per, for the overall model. So,
Right.
so it's good to be first in this case.
And I'm assuming you've probably been able to get your price points down to the point where they're competitive to other products that are out there. They're wired or
Yeah,
speak
absolutely. I
to the
mean,
cloud.
the advantage of our architecture is that, versus traditional compute is that we're generally half the die size. So
Mm.
we're in a spot that, in my 34 years in the industry now, I guess it's an old man's game, is we
Most
can,
startup founders that are really successful actually are not that young.
yeah, well, the young ones show up in the papers and they make movies about them.
That's right. That's right. And the
But
VCs love to, ogle over them, but not necessarily.
yeah, no, I'll tell you, chips is an old man's game. You need to
Yeah.
dot your I's and cross your T's, or you waste a lot of money.
Right.
Uh, but right now we're in kind of a unique position that we can compete on power, performance, or price. As I said, 34 years, I've never had all three. You normally have to
Nice.
give up one of them. So we're in a
Nice.
very good spot.
Sweet. So you're the founder, right? Or one of the
Yes,
founders? So
one of the
tell
four
me a little bit
founders.
about your startup story. I mean, how did you decide to go down this path?
Yeah, so it goes back to the age story. So I was 47 and I was a public company CEO. And I decided it was time to become an entrepreneur.
Nice.
So I looked out in the market. I said, now's the time. So I looked out in the market and realized that, that there really is an opportunity for AI. I mean, we
Mm.
had a nice model going on in the data center, and we can do things at the edge. I realized I couldn't do it myself, so I recruited, some of the best and smartest people that I knew. One is our CTO. Steph Bailey, who's easily one of the 5 smartest people I've ever known. I'd known him for about 18 years when I had invested in his company that was later acquired by Broadcom.
Nice.
And then I needed and then the general idea was generated by our chief scientist Jeremy Holloman, who's a professor, again expert in low power AI. And then you could have a lot of good ideas and you can have good software, which Steph brought to the table, but really it's about execution. And I realized that if you take an idea that comes from a largely academic, cutting edge kind of ideas, you need to pair that with an amazing execution team. And our fourth co-founder, Peter Bornkamp, has built, he was used to delivering millions of units a day when he was at Broadcom to the absolute hardest customers. So he was an
Nice.
early Broadcom employee. So we had this team where Jeremy would come up with a way for us to build one of them. Steph would do the software and architecture. Peter would make sure we could build billions of them, and I would try to extract some money along the way.
Fantastic. I love
So
it.
fast forward, 7 years, we're all still together and still talking to each other. So that's good.
Nice.
So it's better than
Yeah,
some
because
marriages.
sometimes that doesn't work out, but it sounds
Yeah,
like you
no,
guys,
it
there's a
works
lot of
out.
synergy there.
And
So
four
in a lot,
founders is unusual, and we're all sticking together. So that's quite good.
that's good.
Um,
So a lot of times, startups have it like a moment when you realize, okay, this is definitely going to work. I mean, did you ever have doubts before
oh,
that
I'm
moment?
just waiting for that still. No, I'm
Oh, it
kidding.
hasn't showed up yet.
I'm kidding. It's well, the first year was pretty rough. If you turn back time, now everybody's talking about AI and there's a lot of money out there and
Oh, sure.
people are investing, right?
Like
But
I
if you
said,
go
2 years ago, like, when you talked AI, it was like went over a lot of people's heads. They didn't even understand it.
no idea, right? So, especially if you're looking for VC funding. So we were, start January 17, went out and
Now, of course, you can't do anything without having AI in your name.
yeah, exactly. Yeah, I actually should change the A and the I in Syntiant to put AI in.
Yeah, exactly. And capitalize it, right?
Exactly. But I mean, when you said, have any doubts, right? So when we started, 2017, we told our friends we're starting a chip company, and they said, "Yeah, that's really funny. No one's done that in 30 years." I think Atheros was the last successful.
It's time. It's time.
It's time. But it took probably 3 VC pitches a day until we closed our first funding in October of 17. So it took
Nice.
a long, long time.
Yeah.
Um,
Well, you're swimming uphill at the time because you
yeah,
weren't in with the trends.
absolutely
It's
uphill.
good that you got somebody to listen to you. That's awesome.
Yeah, and we were quite fortunate. Intel led our A round, and then a year later, Microsoft led the B round. And I think at that point, we had silicon in hand. We had 2 of the world's greatest tech companies backing us, and great partners for us. And then we had our kind of first design win. It was in a cell phone that was going to ship millions of units. So it was
Nice.
at that point we go, maybe there's something here. I think we got this. So that was really, when we had the industry behind us and we had the customer validation was really a good time when we saw that the thing's going to work.
Right. So if I want to use your devices now, is there any devices that I can go out and buy today that have
There's actually quite a few.
Oh, really?
We don't
Is my iPhone 14 Pro got it in there?
Yeah, no, nothing there. Apple builds their own stuff.
Yeah, of course.
But there's
until they see your stuff in action, then who knows?
You see our stuff all the time. We currently don't disclose customer names, but there's quite a bit. I mean, right now, and I said a couple times, right? A little over 50 million units that are deployed in the field, and they're used because it's Edge AI. They're used like every second, or many times per second.
Nice.
Or inferencing from the real world into those devices.
Very cool. Very cool. And which space are you mostly in right now? You say you were talking about security.
Pretty broad.
Yeah.
So we look at our market in really kind of 5 ways. One is I'd say mobility. So this is things like vehicle tracking, battery management, cell phones, things along those lines. And then we have consumer, which is things that like doorbells and cameras and earbuds and things along those lines, which you've talked about in the consumer area. And then we have areas that we have what basically broadly health. So that's hearing aids and any kind of monitoring or voice activities into the health business. And then lastly, we have a small U.S. government type business that we try to help the U.S. government.
Very cool. Very cool.
Nice.
So it's time to think like a futurist. It's the year 2034. 10 years from now, where will you guys be in 10 years? I mean, this vision that you're telling me, it sounds like ambient computing. Are we talking about ambient computing?
It is. It's effectively ambient computing using AI.
Right.
And so where will we be in the future? So I mean, Syntiant's going to be a pretty good spot. But let's talk about the industry. So if we look back in computing, if like a typical MCU microcontroller, there was no one really knew what to do with these things, and now fast forward a few years or a dozen years, there's even microcontrollers in greeting cards today.
Tell me about it.
Everywhere. So we're going to see the same thing. So we're going to see AI becoming maybe not the dominant form of processing that you see in devices, but it will be present. So you'll see AI in just about everything. And whether AI is interpreting your typing better, or it's making your mouse work better, or it's purely a full natural user interface, no training required. And you might not be able to tell the difference between interacting with a machine and interacting with a person, at least within a certain context. Right. So, if you're, I think a good example is, in your automobile, it's kind of an ideal use case for large language models and talking. So say there's something you want that's buried in this, 500-page manual that no one ever reads, but you could just ask the car. You could say, "Car, how do I do this?" And it just tells you. And it could have a conversation with you of how do you debug things? What does that check engine light really mean?
Yeah.
And
That
so
would be sweet. I would love that.
exactly, we're going to see that without a doubt. You're going to see those kinds of things, and it's just going to elevate, I think, the human experience.
Mm,
And it will be like you will have these, I'd say, pervasive. They'll be both pervasive and invisible. So you won't really notice them. They won't be
yeah.
invasive. So they'll be pervasive, but not invasive.
Yeah.
And they'll be like these digital buddies that help you along your way.
Yeah.
And I think
It's kind
that
of like
is
that they'll completely disappear. It's kind of like the internet sort of has disappeared as a concept, right? It's not a
right.
thing anymore because
It's just
everything.
there.
Yeah.
It's just
Yeah.
there. And you use it for all kinds of things. I mean, it's, my tickets, my directions, my whatever it is.
Yeah. Yeah.
You have that.
So this is actually making, because everyone says smart, like this device is a smart device, but it's not really a smart device. It's a device that just happens to be connected to the internet, like what we have today. For example, this Amazon Echo that's sitting here, it's not really smart, right? The brains are in the cloud,
Brains are in
but
the
this
cloud.
is actually taking the smarts and putting it in the device. So the device is actually becoming smart by
Exactly. We're
having
going to
the
go
AI
from
in it.
smart being connected to smart being smart.
Right. And then the connection is not necessarily required,
Yeah.
right? I mean,
There's a lot of reasons to always have a connection.
sure.
But there's no reason that it always has to be connected.
Yeah. Well, I think I find that seems to be such a key thing, that everything needs to be connected all the time, and they don't take into account how flaky wireless networks are, right?
Yeah.
Wireless networks, cellular networks. There's a lot of issues with them, and you've got things that are, you know, necessarily need to be on all the time. They have to have their own smarts. They can't just have to go to the cloud all the time, right?
Because, well, we're people, right? We're
Yeah.
impatient.
Yeah. Well, not
The
only that, we're in the woods, we're
in the
blocked by a
woods, exactly.
building.
Exactly. So we want a seamless environment or
Yeah.
seamless interaction with things. And if everything has a round trip delay to the cloud, one, it doesn't have that, and two, it's expensive.
Yeah.
So it's much more cost effective, both environmental impact and direct dollars and cents to do things in edge devices.
Yeah, I love this. This is exactly how things should be going, and quickly as possible. So this is great.
We're doing our best.
Awesome. Well, thank you so much. This has been great. So if somebody wants to get in touch with you, what's the best way?
I think it's the best. Reach out to info@syntiant.com.
Mhm.
And I look at those all the time, and that's a great way. LinkedIn is also good.
Very cool. Well, I'll put both the links in the show notes. So if anybody wants to get in touch, they can go direct. So
Please.
thank you so much.
Look forward to it, Chris. It was truly a pleasure.
Talk to you soon.
Take care.
Bye.